Hi everyone, welcome to the Postgres Google Hangout. This is Sakshi from Ashnik. With me, I have Samir Kumar, who is a database solution architect with Ashnik. This session will be run by Samir. I hope you can hear me okay and see my screen okay. If not, please type in the chat window and let us know if there are any issues with the video or the audio. Ashnik is an enterprise open source solutions provider based in Singapore with presence across Southeast Asia, India, and US. We provide Postgres SQL solutions and services across these regions. We are also the master partners of Enterprise DB for Southeast Asia. In a series of Hangouts, we will be sharing the upcoming features of Postgres SQL version 9.6. In today's session, we will be covering parallelism. Over to you, Samir.
Thanks a lot for the introduction, Sakshi. Hello, everyone. I recommend if you have not already done so, go through one of our past Hangouts, which are about topics ranging from replication to NoSQL features of PostgreSQL and building sharded clusters and hybrid cluster in PostgreSQL using foreign data wrapper and other such tools. If you're interested in other open source tools and technologies, Ashnik YouTube channel can also be useful for you for content on Pentaho and Nginx related technologies. Now, to start with today's topic, I will be discussing about the parallelism and parallel query in PostgreSQL. We will start with some of the current features, or rather some of the current parallelism features in PostgreSQL. And we will also look at some of the work which was required to be done to bring server-side parallelism in PostgreSQL. Then we will look at parallel queries in version 9.6 and some of the features which have been released along with beta 1 and some of the parallel plans as well. We will also look at when parallelism is not good or when it is not useful. We will look at some of the new parameters which have been introduced in version 9.6 for parallelism. We'll look at the benefits that user will be getting from this. And then we will be answering some of the questions which you can ask in the chat window, or you can ask them in the question answer app that would be flashing on your screen. To start with, as of yet, in version 9.5 or in the past versions, Postgres currently already offers some level of parallelism, but most of that is either on the client side or is responsibility of the developer. As a developer, you can choose to write a Java code which can open multiple threads. Each thread can make multiple connections, and you can break down your complex batch job into multiple operations or subtasks which are being performed by these threads. You can also potentially use some of the server-side languages to do parallel operations inside a stored procedure which is written in that particular server language. You can also get benefited by the processes like WallWriter and BGWriter, which are basically there to take off the heavyweight writing from the execution process. So the process which is actually executing your query is not going to perform the right operation in Postgres. That is done by WallWriter or BGWriter process. Apart from that, there is also effective IO concurrency, which allows prefetching of pages from the kernel. But despite all this, there is no real server-side parallelism which exists in Postgres. In basically, that means that one query which has been submitted to Postgres cannot be divided into subtasks and given to multiple worker processes. That is the state as of 9.5. Though I would say that there is a lot of infrastructure for parallelism which already exists now in 9.5, and that is what I'm going to talk about on my next slide. Basically, there was a lot of work which was required to be done as the Postgres SQL architecture did not allow creation of background worker processes dynamically, or allocation of shared memory dynamically, or implementation of message queues which were required so that these worker processes can propagate messages back to the master, and hence master can understand whether these worker processes have encountered an error or they have generated a warning message, and the same can be received and propagated by the master process further to the client. Synchronization of various states like GUC parameters, XIDs, current user, current databases, all these needed to be done. Parallel context, which can be used by the backend code to launch more worker processes. All this infrastructure was required before parallel queries can work in PostgreSQL. And all this has been done in previous versions like 9.4 and 9.5. Robert Haas and Amit Kapila were two guys who have majorly worked on these patches. Most of these patches, they have been reviewed by various community members. They have received inputs from many other people in community. And thanks to them all, that today we have something that users can use in version 9.6. Users can already use parallel sequential scan once 9.6 version comes out. And as a byproduct of that, users can also see some of their join plans using parallel joins, and some of the aggregates using parallel worker threads, or I'm sorry, threads would not be the apt term here to use, but rather parallel worker processes can also be serving a parallel aggregation query. Though these all are not in their best form, and people have been discussing about the performance implication of some of this code, and there are some exceptions, there are some limitations as well, but still all this still works, and it is quite useful and it works very well. Basically, the architecture which has been implemented in PostgreSQL to support parallelism is based upon worker processes, wherein a task will be divided among multiple worker processes who would feed in their inputs to a gather node. This is typically the case for sequential scan. And when we look at some of the plans, you will be able to see that after a parallel sequential scan, there will be a gather node which collates all that data. All these worker processes need to coordinate with each other so that they avoid doing duplicate work. For example, some block or something which has already been scanned or done should not be taken up by another worker process. And that is why they all need to talk to each other and coordinate with each other. Now let us look at some of the plans, and let's see parallelism in action. To, to simulate a situation, I have forcefully switched off parallelism. That can be done by switching off max or setting max parallel degree to 0. And as you can see, this particular query, which I'm trying on records which are around 100 millions, that executes in about 103 seconds, and it is doing a sequential scan on the table. Whereas when I enable parallelism with maximum 2 worker processes, I can see that the cost is much lesser compared to the previous version of the query, or rather the previous execution of the query. I can see that this time optimizer planned to use 2 worker processes. Because my max parallel degree is 2, it cannot use more than 2 parallel processes, or more than 2 parallel workers. And it could actually launch both of them because resources were available, and we will get into more details of that later on. See, as highlighted on the screen in the blue rectangle, that parallel sequential scan is happening, and that is an input node, or that is an input to gather node in the explained plan. And as a result of this, you can see that the total execution time is almost 64.5 seconds, which is much lesser than the previous execution, which was over 100 seconds. So this is about 35% gain, a little more than 35% gain, I would say, in the execution time. And also the cost of this query is much lesser. And as you can see, I don't have to do anything to get this. I don't have to run my query at all. I just have to set this parameter, max parallel degree. You may not get as many worker processes as you would want to get, or as you think is appropriate to have. For example, I'm trying to execute the very same query once again, but this time I've set my maximum parallel degree to 10. Now, this max parallel degree is not exactly the degree of parallelism. It does not mean that there will be 10 worker processes. Actually, there would be one more than the the amount of worker processes, because there will be one process which is trying to collate all that data, or which is the master node, or the master process. Now, in this case, you can see the max degree of parallelism that I have set is 10. So max parallel degree is 10, but Postgres decides that the best degree of parallelism, or most optimum number of worker processes, would be 7. So it decides to request for 7 processes, but it actually gets only 2 of them, because there is a limit to the number of workers which can be launched, or which could be running for various requests at a given point of time. And if none of them are free, you cannot launch more than that particular limit. And it is a hard limit. It is a limit which can only be set on the startup time. There is a parameter for that, and we will look at that in one of the next slides. Now you can see that over here, the query cost is the lower, the execution time is little higher, because I was also running another query in one another window. And that is why there was a contention for resources, and that is why the this particular execution could not get the number of workers it had planned to use. Now let's look at some of the other plans which can benefit from parallel query in 9.6. I can also use or see the benefits of parallelism when I'm performing aggregate queries. For example, when I say count star from a particular table, it will do a parallel sequential scan, and which feeds into partial aggregate. So each of the worker process which is doing a sequential scan will feed into partial aggregate node, and all those nodes which are doing partial aggregates will gather that data in the gather node, and the final aggregation would be a result from the gather node. As you can see here, there are parallel sequential scans happening. It planned to use 2 worker processes which it was able to launch, and that feeds into a gather node which finally goes to finalized aggregation. I can also use, or rather see, benefits of parallelism in parallel joins, though in my own experience I could not see the benefit of parallel joins in most of the parallel queries, or rather the join queries which I was trying to fire. But I had to force optimizer to use parallelism, and that is how I could simulate this case, or this plan, where I can see that there is just 1 worker process working for the master process, and it is collecting all that data and doing the join, sending it to the gather node, and finally you get the output. Now I will come back to that, how I could force optimizer to use parallelism here, but this was just for simulation purpose. This, as you can see, the time is almost 330 seconds, whereas without parallelism this query takes much lesser time actually. And that brings to another important aspect of this discussion, which is, as we had seen in past, some of the queries could really benefit from parallelism. Like the first query we saw, it was 35% gain. And that would make me think that, hey, why don't we use parallelism all the time, and we should prefer using it? Well, it may not be useful all the time, and also it may not be used by PostgreSQL all the time. So PostgreSQL has a cost-based optimizer, and that cost is determined based upon various cost factors, like cost of scanning a particular table, cost of scanning indexes, cost of doing a join, cost of launching worker processes, cost of parallel scan, or parallel evaluation of tuples. Because of that, or because of these all parameters and these all factors, the cost of parallelism at times could come out to be higher, or cost of provisioning that infrastructure for parallelism could come out to be higher than a sequential or non-parallel query. At times, it is also possible that you are trying to look for, or trying to launch worker processes, and there is no worker process available. Your system has already reached the maximum limit for parallelism, and hence it is not able to launch any new worker process. Because of these various regions, your optimizer may choose to go without parallel execution, and hence it may execute it in the traditional way. As you can see in this case, I'm trying to do a select from a particular table which has just 1000 rows, and most likely just one page. Just one page has all the data. And here, as you can see, even if I have enabled parallel degree, I've set max parallel degree to 2. I have allowed PostgreSQL to use maximum 2 parallel worker processes. Still, it is not using them. Still, PostgreSQL decides that a simple sequential scan is more efficient. And perhaps it is right. As you can see, I'm trying to do an aggregate query here on a table which has around 100 million rows. And on that, when I'm trying to do a count star with different levels of parallelism, the best result I got was when I used no parallelism, be it in terms of the response time or be it in terms of the cost of that query. In this graph, the lower value is better, which means lower the time taken, better the query performance, lower the cost, better the query performance, or more optimized was the execution. So as you can see, as I increase the degree of parallelism to 1, the query performance degraded. It further degraded when I increased it to 2, but it became a little better when I started increasing the degree of parallelism further until at with 5 worker processes, it gave me somewhere around 60 or 70 odd seconds. It took around 60, 70 odd seconds to execute the query, as compared to around 45 seconds, which it had taken when I was using no parallelism. So while you can force by tweaking your cost parameters or by forcing optimizer to execute a query in parallel, it may not be useful all the time. A parallel query may not be good all the time. It depends a lot on your hardware. For my specific use case, I was running on a 3 CPU and 3 GB RAM virtual machine, which was running CentOS. I had a single disk, which was also a virtual disk. So I had scarcity of hardware resources, and that is why you can see that there is no benefit of parallelism. And the when I set the degree to 0, as when you're doing count star, Postgres might use an index, and that is what it was doing. That is what it was doing when I was when I was not using parallelism. The index scan was much faster than parallel sequential scans. So in order to make sure that your optimizer is using parallel queries only when it should be using, you should be tuning your parameters right. And let's look at some of those parameters which are involved here. There is a new cost parameter, like you must be already aware of other cost parameters like CPU tuple cost, sequential page cost, random page cost, which basically designates the cost factor of each of these operations. Similarly, there is now parallel setup cost and parallel tuple cost, which basically would assign cost factor for setting up parallel infrastructure for a particular query and parallel processing of tuples, respectively. You can also restrict the maximum number of worker processes which could be running in your system. This is a global setting, which means this setting impacts total number of worker processes which could be running for all the current queries. You can also set max parallel degree at the global level, which means this is defaulted to every session and every query, which is 2 by default. And you can increase that in a session, or you can increase that for a particular transaction. You can also set parallel degree at the table level. You can also benefit from parallel scans or parallelism for your functions, but make sure that you mark them as parallel safe. So you can alter your functions and set them parallel safe. You can also tweak the cost of your functions so that optimizer decides to use parallel operations for them as and when it can. If your costs are too skewed or they are not optimized for your functions, you may see that your optimizer may choose a parallel scan when it should not be choosing it, or it may not choose a parallel scan when it is going to benefit from it actually. There is another parameter that you see on my screen which has been marked in red, and it is because it is dangerous to use it. It is to force parallel mode. You should not be using it in your production. You should not be setting this parameter in your postgresql.conf. You should set it only for specific sessions when you're testing parallelism, or when you're testing your theory or your assumptions that this query or a particular given query can benefit from parallel execution. Otherwise, do not set it in general. It could be dangerous. It will start forcing every query to start using parallelism. I did that for a query which was involving 3-table join, and without parallelism, or rather without forcing parallelism, that query could complete within 20 seconds. When I forced parallelism for that particular session, that query did not return back even after 15 minutes. So be careful when you're setting this particular parameter. In fact, you should not be setting it at all. You should only set it temporarily for a particular session and never in your server level parameters. Now, let's come to some of the benefits which parallelism brings to PostgreSQL users or people who plan on using PostgreSQL this year or the year next to us, which is 2017. Those users who would start using 9.6, they will be able to use sequential scan for larger table, and those would be faster. Any analytics workload which involves aggregation like summation, max, count, they all should be able to benefit from parallel aggregates. Joins between large tables should be faster, as in when it can use Postgres optimizer would choose to use parallelism for those joins, and it should be performing faster than previously. 9.6 and all these features makes 9.6 a very good candidate for data warehouse database. So if you're starting a new data warehouse database which has usage of analytics queries, summation, and all these things, you can use PostgreSQL very well. You can do a lot more parallel operation in the future releases. The next release of PostgreSQL after 9.6 would be called 10.0. This has been recently decided and announced at PGConf Ottawa. Now, as a user, what can you do? PostgreSQL Beta 1 for 9.6 is already out. Test it out, try to break it, file a report, file a bug, share your experiences with PostgreSQL community so that they can take that feedback and make it better, fix a code, fix a bug, and make sure that parallelism does not break. And that holds true about other features of PostgreSQL as well in 9.6. You can download the beta 1 from EnterpriseDB website, which has a packaged installer for PostgreSQL, open source PostgreSQL 9.6. You can also get the source code or some of the binary or RPM packages from community website and install them and try it out. If you're interested in reading further about the journey of parallelism in PostgreSQL, I highly recommend you to go through some of these blogs and presentations by Robert Haas and Amit Kapila, who have done a lot of work for setting up the infrastructure for parallelism in PostgreSQL, and they were also the coders or people behind sequential scan and also the parallel joins in PostgreSQL 9.6. So they have done a lot of blogs and a lot of presentations around this whole journey. If you're interested in looking at a brief of various 9.6 features, you can go through the Magnus Hangander's presentation, which he did at PGConf 2016. I was fortunate to be present there and you know listen to him and also interact with a lot of other PostgreSQL developers and committers. This is all from our side for this particular Hangout. Stay tuned. In one of our next Hangouts, we would be talking about other PostgreSQL 9.6 features, which are including the synchronous commit enhancements, the auto vacuum enhancements, and other great features. So stay tuned. If you have any questions or suggestions, send it to us. And if you have asked any questions, let me go back to the screen, to the Hangout screen, and check if there are any questions. Well, yes, just to repeat the question, someone has asked, what are the aggregate functions which can make use of parallelism? Well, not all the aggregate functions will be able to use parallel query. Most of them should be able to use it, but string function, JSON functions may not be able to use it. If you have ordered sets, those those cannot make benefit or take benefit of parallel queries. Okay, yeah. So the next question is about when will be the next Hangout, and the next Postgres Hangout, we should be doing it sometime next month, where we would most probably be sharing something about the synchronous commit features, or the synchronous replication features, which are new in 9.6. Not exactly features, but the enhancements, which includes multiple synchronous standbys and remote apply feature. Thanks a lot, everyone. Thank you for joining us today.